Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The structure shown is a cyclohexane 1,3,5-trione, a tritone ring with 3 substituents, a tert-butyl group, a cyclopropyl-methyl CH2 cyclopropyl group, and a phenyl group. This type of compound is characteristic of a fluoroglucinol 1,3,5-cyclohexanetriene derivative, which is the keto tautomer of a trihydroxybenzene. Moving on to the next step. 1,3,5-cyclohexanetriene fluoroglucinol keto form is in equilibrium with its enol form, which is the aromatic compound 1,3,5-trihydroxybenzene fluoroglucinol. Under complete acidic hydrolysis, the substituted cyclohexanetriene can undergo retronoevenagel or retromichael type cleavages as well as tautomerization to give aromatic products. Moving on to the next step. Under complete acidic hydrolysis conditions, the tritone ring can open or tautomerize. The key products to consider for aromaticity are 1. Fluoroglucinol 1,3,5-trihydroxybenzene formed when the cyclohexanetriene enolizes fully to the aromatic tautomer. This is aromatic count 1. 2. The phenyl group is already on the ring as a substituent. When the ring fragments, benzoic acid or benzaldehyde or phenylacetic acid type compounds containing the benzene ring can form. The pH group attached to the ring carbon, upon hydrolytic fragmentation under acidic conditions, would give a compound containing the phenyl benzene ring count 2. And for the final step, the cyclopropyl-methyl group, CH2 cyclopropyl, is not aromatic. Cyclopropane is not aromatic. The tert-butyl group is not aromatic. 1. Fluoroglucinol 1,3,5-trihydroxybenzene from the cyclohexanetriene ring aromatizing via enolization. This is the aromatic product of the ring itself. 2. A benzene-containing fragment from the phenyl substituent, example, PHCHO or PHCOH or similar compound containing benzene ring. These are the 2 aromatic compounds produced. Only one would miss the phenyl-containing fragment. 3 or 4 would require the cyclopropyl or tert-butyl groups to give aromatic products, which they cannot. Hence X is equal to 2. Therefore, the correct answer is B. Therefore, the correct answer is option B.